So with this method here, this is something that we've kind of already seen when we have done that factor by grouping practice in the past couple notes. This is the method that most everyone uses. This is the easier way. Okay. So this is chapter 4.4, factoring trinomials when a is greater than 1, and this is using the AC method. Okay. So here are the steps of the AC method. So just like the other method, we're factoring out a GCF if there is a GCF. Okay. Then we are going to be multiplying the coefficients of A and C. So that's why it's called the AC method, because you are going to be multiplying A times C. Then we are finding the product of A and C. That sum is B. So we kind of did that a little bit when we did the factor by grouping before. So you'll see that in the examples. Then you will rewrite that middle term as a sum and then do factor by grouping. So those are the steps. Let's go ahead and see that visually in the example. So first thing we're checking is that this is in the correct order. Is this in the correct order? Yes, because we have our 2x squared, then our 7x, then our 6. So all our x's are in order. Now we're checking if there's a GCF. Is there a GCF? No. So since there's not a GCF, I'm just labeling my coefficients. So this is my A, my B, and my C. For this method, I have to multiply my A times my C. So I have A times C, which is 2 times 6, which is 12. Okay. And then I write my B value, which is 7. So creating my table, I need factors of 12 that when I add them will give me 7. So first let's just list those factors of 12. We have 1 times 12. What else do we have? And 3 times 4. So just checking those two factors, if I add 1 and 12, that will give me 13, which is not 7. But if I add 3 and 4, that gives me 7. So that means the factors I'm going to be using this problem are 3 and 4. Everyone following me so far? Okay. So now what I'm going to do is I am going to take that 7x and I'm going to write it in terms of 3x and 4x. I'm separating that 7x into two parts. So I have 2x squared plus 4x plus 3x plus 6. Notice that this problem has not changed because 7x is the same as 4x plus 3x, correct? Now that I have 4 terms, I can do factor by grouping. Notice when I start factor by grouping, why did I not write 3x plus 4x? There's a reason I wrote 4x then 3x. Any thoughts? It's not wrong either way you do it. There's just a reason I did it this way. Because look at my groups.
Oh, to keep the ratio the same between the two of them.
Good. So like if since I put the 4x first, when I'm going to have to find a GCF out of this first term, look how I have a 2 and a 4. That's easy to find the GCF from. Same with this one. I have a 3 and a 6. It's not wrong if you put them the other way. You're going to get the same answer. I'm just going to place this in a way that is the easiest for me to solve. Okay? So that's just something to point out there. So now going back to my factor by grouping, I'm going to be taking the GCF out of the first parentheses, and that GCF is going to be a 2x. And I'm going to be left with x plus 2. And then the GCF of the second parentheses is going to be a 3, and I'm left with x plus 2. What do we remember when we did factor by grouping? These parentheses have to be what? The same. If they're not the same, what does that mean? You did something wrong. Your math's wrong somewhere. These have to be the same. So that means my answer here is that 2x plus 3, everything that was on the outside, and then that x plus 2. That is my factor. So this is a lot less steps than doing that trial and error method, that guess and check. That's why everyone prefers the factor by grouping. Okay. Any questions on number 1? Okay, let's look at number 2. So first thing we're checking in number 2 is that everything is in the correct order. Yes or no? Yes, we got our x squared first, then our x, then our coefficient, that constant. Okay, now we're checking if we can take out a GCF. Yes or no? No. So we're going to go ahead and just start labeling. So we have our A, our B, and our C. And what's our first step? Multiply A and C. So we have A times C, which is 2 times 3, which gives us 6. Okay. Then we have our B value of 5. So now I need all my factors of 6. So what's one factor of 6? Good, 2 and 3. Anything else? 1 and 6. So now I check those factors to see if I add them together, if I will get 5. So 2 plus 3 gives me 5, so that's good. But if I check 1 plus 6, that gives me 7, which doesn't work. So that means my factors I'm going to use here are what two numbers? 2 and 3. Okay, so I would expand my 5x to be a 2x and a 3x. So which one would be easiest to write first, the 2 or the 3? The 2. So I'd write 2x plus 3x plus 3. Why is it easier to write the 2 first and not the 3?
They're in the same
Yeah, it's because when we are doing our groups, it's easier to take a GCF when our numbers go together. So this 2 and 2 and the 3 and 3. Okay. So now factoring out a GCF from each of them, what GCF are we going to take from the first parenthesis? 2x. And if I take out a 2x, I'm left with x plus 1. And what GCF would I take from the next parenthesis? 3, and I'd be left with x plus 1. Are they the same, the parentheses? Yep, so that means I did something right. So that means my answer is 2x plus 3, x plus 1. This is my factor for that trinomial for number 2. Okay, let's look at number 3. First step, is this in the correct order? No. How would we write this in the correct order? Good. 8x squared minus 2x minus 3. Has to go, our x's have to be descending. X squared, x, and then nothing. Is there a GCF I can take out of this? Yes or no? No, so I'm just going to go ahead and label my A, my B, and my C, and start multiplying my A times C. So 8 times negative 3 gives me negative 24, and my B value is negative 2.
Are you wanting us to specifically label the coefficients A, B, and C, or as long as we have like our numbers on the table in the right spots?
As long as you have your numbers on the table, yeah. I'm just showing every single little tiny step, yeah. Yeah, I'm not going to mark off on a test if you didn't label A, B, and C, unless that was the question. If the question is, what is A, what is B, what is C, then of course, then you would have to label A, B, and C. Okay, so looking at our factors, what are some numbers that multiply to negative 24? negative 6 and 4. Anything else? So we're ignoring our b value right now. We're just looking at factors of negative 24.
2, negative 12.
Good. 2 and negative 12.
1, negative 24.
1, negative 24. You do negative 3 and 8. There's a whole bunch of them. So just with the ones I have, I'm first going to check if I add them together, I'm going to get a negative 2. Okay, so starting at the bottom, if I add those together, I get a 5, which does not work. Then I get a negative 23. Again, does not work. Again, I'm just showing you the process that you would go through if, let's say, you just couldn't find the one that worked. But we found it in the first try because negative 6 plus 4 does give us a negative 2. So we're going to be using that negative 6 and 4. But again, you would continue this table and do this method if you could not find those factors right away. What would I write first when I'm splitting up that negative 2x? Would I write a negative 6 or would I write a 4? A 4, because that goes with the 8 more than the 6 does. So 8x squared plus 4x minus 6x minus 3. Remember, I'm expanding that negative 2x into the factors that I found. From here, I group and take the GCF from each one. So what would be the GCF of the first parenthesis? 4x, and that would leave me with 2x, because 8 divided by 4, got 2x plus 1, because 4x divided by itself is going to give us 1. Okay. What am I taking out of the second parentheses? Okay, so I could take out a 3, but if I take out a 3, will my parentheses match at the end? No, because I'll have a negative 2x and a negative 1. So that's why I need to take out a negative 3. So when I divide that, I get 2x plus 1 because my parentheses have to be the same. They're not the same, then you did some math wrong in the beginning. So that means my answer here is 4x minus 3 and 2x plus 1. Okay, let's look at number 4. Is this in the correct order? No, so let's write it in the correct order. So 6w squared plus 13w plus 6. Can I take out a GCF? Yes or no? What would be the GCF if you're saying yes? Is 13 divisible by 6? So it can't be 6. So looks like we can't take out a GCF. So I'm just going to go ahead and start my A times C. So A times C is 6 times 6, which is 36. And then my B value is 13. So I need factors of 36. So what two numbers multiply to 36? 12 times 3. What else? 4 times 9. And of course that's 6 times 6, that in the beginning. And let's just go ahead and leave it as those because I see my answer already in there. Now I add these numbers across to see if I get 13. 12 plus 3 is 15, so that doesn't work. 4 plus 9 is 13. That works, so right away I know that's my pair. I'm going to go ahead and just add the rest. 6 plus 6 is 12, not 13. Okay, so from here I got my factors of 4 and 9. So I'm going to do 6w squared plus 4w plus 9w plus 6. And then do my factor by grouping. What would be a GCF I could take from the first parentheses? 2w, and I'd be left with what? Plus 2. Good, because 6 divided by 2 is 3. W squared divided by w is w. And 4w divided by 2w is 2 because the w's cancel out. Okay, what about from my next parenthesis? A 3. So if I take out a 3, I'm left with 3w plus 2. Do they match? Okay, so that means my answer is 2w plus 3 and 3w plus 2. It's my factor for my problem. Okay, any questions so far? Okay. Let's look at number 5. Okay, so number 5, we're just checking if it's in the correct order. Is it in the correct order?
Yes.
Yes, because we have x cubed, then x squared, then x. It's descending in x's, so we know that's in the correct order. Is there a GCF that we could take out?
Yes.
What would be that GCF?
I believe just 5.
5x. Good. Because each of them have an x value, we can also take out an x. So we're going to take out a 5x. So that means I'm left with 2x squared minus 85 divided by 5. Is it there? 17. And then x, okay. And then plus 105 divided by 5, 21. Okay. Okay, so we factored out our GCF. So right now we're just dealing with this inside. Okay, we're going to bring the GCF down when we have our answer, but for now we're just looking at that 2x squared minus 17x plus 21. So I have my a, my b, and my c value. So I do a times c. So a times c is 2 times 21, which is 42. And then my b is negative 17. So I need factors of 42. What would be those factors? Good, 2 and 21. So right off the bat, whatever they gave us in our original one. 6 and 7. 3 and 14. 3 and 14. Okay. 1 and 42. Looking at these, though, if I add any of those together, I'm only going to get a positive number. So what does that tell you?
We need the negatives.
We need the negatives, and that both of our numbers are going to have to be negative. So based off just what we have, what do you think the factors are?
Negative 3 and negative 14.
-3 and -14. Okay, because we need a negative because a negative added to a negative gives us a negative number, and a negative times a negative is a positive number. So right away we know if we add these, we're going to get that negative 17, which we want. All of these are going to give us positive numbers, so it couldn't be any of those. Okay, so I have 2x squared minus 3x minus 14x plus 21. Okay. I just wrote out whatever my factors were in that order to show you that even though I didn't match up the 14 with the 2 and the 3 with the 21, I'm going to get the same answer. Okay. Just I'm going to, it's not going to make it more complicated. I just like to match up my numbers to make it easier when finding the GCF. But I just expanded that negative 17x to negative 3x minus 14x. So now I'm grouping. and taking out the GCF. So what would be the GCF between 2x squared and negative 3x? Just an x. So I'm left with 2x minus 3. What about from negative 14x and 21? 7. If we take out a positive 7, would that give us a positive 2x? No, because remember we want our parentheses to match. So instead of taking out a positive 7, we should take out a negative 7. So then we would be left with 2x minus 3. Remember, we want these parentheses to match. So that means my answer is x minus 7 and 2x minus 3. And I have to bring that GCF down, place it in the front, so then I have my entire answer. Okay, so if you take out a GCF in the beginning, you have to make sure to add that to your answer at the end. If you did forget that on a test, I wouldn't mark the whole thing wrong, but I would take off points. Okay. Now let's look at number 6. So first of all, is this in the correct order? Yep, because our y's are descending. Can we take out a GCF? Yes, what would that GCF be? Good, 3y. So if we took out a 3y, we would be left with 3y squared minus 10y plus 8. Okay, and that was us dividing that by 3y. Now, just looking at the inside terms, I'm multiplying my a times c. What is a times c in this case? 3 times 8, which gives us 24. And our b value is 10 or negative 10? Negative 10. Always include that sign in front of it. So looking at our 24, what are some factors of 24? Negative 2 and negative 12. Okay. Negative 2 and negative 12. Okay. Negative 6 and negative 4. Do we already see our answer here? Which one is it?
The second one.
The second one, because if we add those together, we get negative 10. Okay. If you see your factors right away, I don't expect you to complete the whole table with all the factors. If you see it right away, just write it, circle it, so I see that you showed that step. So now I'm going to expand that negative 10y. So I have 3y squared minus 6y minus 4y plus 8. Do my factor by grouping. And then I take the GCF out of each parenthesis. So the first GCF is going to be 3y, because they both have y's. So I'm left with y minus 2. And then what about the next one? Because I want my parentheses to match. Negative 4. Because if I take out a negative 4, I'm left with that positive y and the negative 2. So that means my answer is 3y minus 4, y minus 2, and I bring down that GCF of 3y. Okay. Let's look at number 7. Okay, and number 7, what do we see right off the bat? We don't just have x's, we also have y's. And what do we do when we see that? What are we going to do with the y's in the beginning? Ignore them. We're ignoring the y's. So I have negative 18x squared plus 21x plus 15. So now looking at this, is everything in order? Yes. Are we going to have a GCF? Yes. What is that GCF? So 3 is correct, but remember we don't want a negative number in the beginning. So instead of just taking out a 3, we should take out a negative 3. So that negative right here in the beginning tells you right away that we have a GCF, even if that GCF is just going to be negative 1. Okay, we don't want a negative in that a value. Okay, so if I take out a negative 3, I'm left with 6x squared minus 7x minus 5. Okay, so now I'm just looking at what is inside my parentheses. So I have my a, my b, and my c value. So if I do a times c, what am I going to get? Negative 30. And what's my b value? Negative 7. So I need 2 factors that multiply to negative 30 but add to negative 7. What would be those 2 factors? And if you can't think. Good, so it's definitely 10 and 3, but one of them has to be negative. Which one? Negative 10 and positive 3. Because if we add that together, we are going to get a negative 7. Okay. If you can't think of that right off the bat, you list all your factors. Okay, and then you just check one by one. So I have 6x squared minus 10x plus 3x minus 5. Again, I'm showing you that it doesn't matter which order you place those 2 factors in the middle. You're still going to get the correct answer. So looking at the first parenthesis, what are we going to take out for the GCF?
2.
A 2. Anything else?
X.
X. So if we take out a 2x, we're left with 3x minus 5. That matches that other parenthesis, right? Or they already match, which means what GCF am I taking out if they already match? I don't need to change it.
Yours.
Good, a 1. So I'm just taking out a 1. That way my parenthesis stays the same. Right? Because if I was to distribute that 1 back in, it wouldn't change it, correct? And I have to have these be the same. But I can't just have nothing here. I can't leave that blank. There has to be something there. So in order to take something out and not change it, that's always going to be a 1. So that means I have my parentheses of 2x plus 1, 3x minus 5, and then what's going to come out in the front? Negative 3. Okay? But remember in the beginning, we ignored our y's. So where are those y's going to go? At the end of our parentheses, like at the end inside of them. So it's negative 3, 2x plus y, and 3x minus 5y. I just attached the y's to the last terms in those parentheses. Any questions on number 7, how we got the answer here? Okay, now let's look at number 8. So what am I going to do first with number 8? Ignore the y's. So I'm crossing them out for now. So now I have negative 8x squared minus 8x plus 30. What's the next step that I'm checking for? See if it's in order, right? And it is, because it goes x squared, then x, then a constant. Then what's the next thing I'm checking for? GCF. And right away I know this has a GCF because what? That negative right in the front tells me I have a GCF. So what's the GCF for this problem? Negative 2. Good, so I'm going to take out a negative 2, and I'm going to be left with 4x squared. Let's see, plus 4x minus 15. That was me taking out a negative 2. So now I have my A, B, and C value. So A times C is 4 times negative 15, which is 60, negative 60. And B is that 4. So we need two numbers that multiply to negative 60, but will add to 4. Can anyone think of what those two numbers are? Or if we can't think of them right off the bat, we'll just start listing factors of negative 60. You said 6 and negative 10? Okay, yep, 6 and negative 10 gives us negative 60. If I add that, will that give me a positive 4? No, so what should I do with the sign? Switch it. So negative 10 and a positive 6, if I add that, will give me a positive...
You didn't change your sign.
I didn't, yeah. Negative 6, positive 10. If I add that, will give me a positive 4. Okay. So rewriting this, I have 4x squared minus 6x plus 10x minus 15. That was me expanding my middle terms. Now that I have 4 terms, I put them in parentheses and start taking out the GCF from each one. So what's the GCF of the first one? 2x, and I'd be left with what? 2x minus 3. Okay, what about the next one? A 5, and I would be left with 2x minus 3. My parentheses match, so I know I'm going to have 2x plus 5, 2x minus 3. And what are the two things I need to bring down for my answer? The y and the GCF. So I'm bringing down that GCF, so I have negative 2, and then I'm going to place my y's where?
After the 5 and then negative 3?
Good. After that 5 and negative 3, at the end of my parentheses, so 2x plus 5y, 2x minus 3y, and that's my answer. We don't want to forget about the y's that we ignored, and we don't want to forget about that GCF. Okay. Number 9. Number 9 should not have that squared there. It should just be 2x squared plus 5x plus 2. Okay, so we know it's in order. Is there a GCF we can take out? No, so we just label our A, B, C. So that means our A times C is what number? 4, and our B value is 5. So I need 2 factors of 4 that will add to 5. 4 times 1, good, because if I add that, gives me 5. So I have 2x squared plus 4x plus x, because I don't need to write 1x, plus 2. Draw my parentheses and start taking out my GCF. So what would be the GCF from the first one? 2x, so I'm left with x plus 2. And since that already matches my parentheses, what am I taking out? A 1, so I have x plus 2. That way these stay the same. So that means I have my answer of 2x plus 1 and x plus 2. Okay, first we're checking, is this in order? Yes, because we have y fourth and y squared and then nothing. Okay. Can we take out a GCF? No, we can't take out a GCF. Let me see what I have for this one. Let me see if this was another one that was a typo. No, okay. So we're not taking out a GCF. We're going to go ahead and use what is called U substitution, okay? Because technically what we want this to look like is ax squared plus bx plus c, right? Because we want an x squared and an x, or in this case, a y squared and a y. So with U substitution, what we do is we're going to label our u as whatever variable is attached to our b value. So the variable attached to b value. So in this case, u is going to be equal to what? What's the variable attached to the b value? Y squared, right? The whole thing is attached to the b. So if we were to square u, that would be y squared squared, which gives us y to the... What happens when you square a square? You multiply it, right? So 2 times 2 is 4. So now I'm going to rewrite this problem in terms of u. And you'll see what happens here when I do that. If I rewrite this problem in terms of u, I have 3u squared plus 2u minus 8. Does this look like a problem now that we are able to factor?
Yes.
Yes, because we have a variable squared, then we just have our variable by itself, and then we have a constant. So it looks like that ax squared plus bx plus c. So what I'm going to do now, label my A, B, and C, and do the same thing I did before. So A times C gives me what number?
24.
Negative 24. And what's my B value? 2. So I need two numbers that multiply to negative 24, but added 2. 6 and negative 4, perfect. 6 times negative 4. If I add these together, it gives me a positive 2. So that means I have 3u squared plus 6u minus 4u minus 8.
So the y turns into...
For now, we're going to end up having the y back in our original problem. But if we were to try to solve number 10 as is, we don't have a method of factoring a y to the fourth and y squared, especially since our negative 8 at the end doesn't have a y2 to take out. Okay, so this is why we use U substitution. This is an advanced concept, this concept. I don't believe this is on test 2. This is just something to explore. Okay, so now that I have this, I'm going to do my factor by grouping. So what can I take out of the first parenthesis? 3u, and I'm left with u plus 2. Good. What can I take out of the next one? -4, and that way I'm left with u plus 2, because they have to be the same, the parentheses. So that means I have a 3u minus 4 and a u plus 2. Is this going to be my answer?
No.
No, because my original problem was in terms of y. So I need to plug in what u is equal to get my y's back. And what did we say u is equal to?
Y squared.
Y squared. So I have 3y squared minus 4 and y squared plus 2. That's my answer. And that was because u is equal to y squared. So this is a little like the concept of the problems like, I believe it was like 6 and 7, or 7 and 8, where we had that extra variable in there and we had to cross it out and ignore it in the beginning. It's kind of like that same concept. But instead of having multiple variables, we had variables with very high exponents. Okay? So you know right away that you have to use u substitution if you have a variable to the 4th and a variable squared and nothing here. That's how you know you're using u substitution every time. You have a variable that's raised to the 4th power, a variable squared, and nothing here at the end. Okay. Any questions on